Dear students, welcome to my fourth class on Module 4, Vector Space and Orthogonality. To solve the problems related to linear combinations, linear span, linear independence, linear dependence, basis, dimensions, and in four fundamental subspaces, finding rank and finding pivot numbers plays a major role. For this purpose, in this lecture video, we're gonna see about how to find the rank and how to find the pivot number by using row reductions concepts. How to find rank? So we know that the rank can be calculated by echelon form. So this echelon form can be obtained by row transformations only. So like after getting the echelon form, we can able to calculate the number of non-zero rows in the echelon form. So the number of non-zero rows will be equal to the rank of the given matrix. And this echelon form can be obtained with zeros below the pivot. Now the question is how to calculate the pivot elements. So to calculate these pivot elements, we have to satisfy few conditions. The first condition is pivots are the first non-zero entries in all the rows. The first condition is the pivots are the first non-zero entries in all the rows. The condition number 2 is the pivot should be unity. That is, it is represented in the form of only plus 1. The third condition is below each pivot is a column of zeros obtained by the row reductions. So below the pivot numbers only zero column must be there. And finally, to identify the pivot numbers, we can observe a staircase pattern below the pivots and all the zero rows must be below the non-zero rows only. So with this condition, we can able to identify the pivot numbers by using the echelon form, by using the row transformation. And we have to know that to get a echelon form, we have to perform only row transformation. We should not perform any column transformation in this case. Problems. Problem number 1. Find the rank of the following matrix. A is equal to 1, 2, 1, minus 2, minus 3, 1, 3, 5, 0. So now from this matrix, we have to find the rank of the given matrix. So to calculate the rank, we have to reduce the matrix into echelon form by using row transformations. By calculating the number of non-zero rows, we can able to find the rank of the matrix. So given matrix is A is equal to 1, 2, 1, minus 2, minus 3, 1, 3, 5, 0. So always we have to make the first entries of R2 and R3 rows 0. So I'm making the first row as R1, second row as R2, third row as R3. So in the first step, my aim is to convert the first entry of R2 and R3 to 0. So by the row reductions, to make this one as 0, I'm going to use R1 row. That is R2 implies that R2 plus 2 R1. I'm going to multiply 2 for the R1 row and I'm going to add with R2 row for the R2 row alone. For R3 row, to make this first entry of R3 row 0, the operation is R3 implies that R3 minus 3 R1. I'm going to multiply 3 for the row R1 and I'm going to subtract with R3 row. So like after reduction, I got the matrix A is equal to 1, 2, 1. Like by using this simplification, it will become minus 2 plus 2, it is 0. Minus 3 plus 4, it is plus 1. 1 plus 2, it is 3 with this equation. Similarly for R3 row, I'm going to use this equation. 3 minus 3, 0. 5 minus 4, 5 minus 6, it is minus 1. 0 minus 3, it is minus 3. So I got this equation, this matrix. Now to make this entry as 0, this minus 1, I'm going to make 0. So for this purpose, I'm going to add this R3 with R2 row. So that is R3 implies that R3 plus R2. So the matrix will become A is equal to 1, 2, 1, 0, 1, 3, 0, 0, 0. I got it. And we can note that this matrix having two non-zero rows, and the first entry of the non-zero row is 1, and these two will be called as in pivot numbers, and the rank of this matrix will be equal to 2. Problem number 2. Find the pivots of the following matrix. A is equal to 1, 3, 3, 2, 2, 6, 9, 7, minus 1, minus 3, 3, 4. So for the given matrix, we have to find the pivot numbers. I mean the place of the pivot numbers we have to identify here. So take the given matrix A is equal to 1, 3, 3, 2, 2, 6, 9, 7, minus 1, minus 3, 3, 4. Now I am going to call the row 1 as R1 row, this row as R2 row, the third row as R3 row. Now I am going to perform few row transformation. So to make this first entry of R2 row 0, the operation is R2 implies that R2 minus 2 R1. I am going to multiply 2 for the row R1 subtracting with R2 row. To make this the first entry of R3 row 0, I am going to add R3 with R1 to get the 0 entry here. That is R2 implies that R2 minus 2 R1 and R3 implies that R3 plus R1. So like after performing the operation, I am keeping the R1 row as it is 1, 3, 3, 2. Performing operation here, 2 minus 2 it is 0, 6 minus 6 it is 0, 9 minus 6 it is 3, 7 minus 4 it is 3. Similarly, adding this, minus 1 plus 1 it is 0, minus 3 plus 3 it is 0, 3 plus 3 it is 6, 4 plus 2 it is 6. Now to make the last row as 0, to convert this last row as 0, the operation is R3 implies that R3 minus 2 R2 I will be making. So subtracting, multiplying 3 for R2 row, subtracting with R3 row. So I got the matrix like A is equal to 1, 3, 3, 2, 0, 0, 3, 3, 0, 0, 0, 0. We got it. So now the obtained row reduced form is an echelon form. So now the next step is to find the pivot elements. So now to make the pivot elements, I am going to convert this 3 as 0. Actually, this step is not mandatory, but I am making the equation now. R1 implies that R1 minus R2 to make this entry as 0. Like after this one, the matrix will be of the form A is equal to 1, 3, 0 minus 3, 0, 0, 3, 3, 0, 0, 0, 0. We got it. And we know that the first entry of the non-zero row must be always 1. So to convert this entry as 1, I am going to divide the entire equation with 3. So like after dividing, I got the equation like matrix like 1, 3, 0, minus 1, 0, 0, 1, 1 and 0, 0, 0, 0. So from this matrix we can able to see the pivots. So here the first entry of R1 row is pivot and the first entry of the R2 row is pivot, and we can observe that all the pivot numbers are 1 and all the 0 columns below the pivot number only, and all the 0 rows also below the pivot numbers only, and we can see a staircase pattern here. So this one and this one will be called as a pivot numbers. In the next lecture video, we will discuss linear combination and linear span, the problems on the linear combinations and linear span. Thank you.